All right, so the only difference between 87 and 86 is that, one, it has a degree of 4. Okay? They give you 3 zeros, right? But one of those zeros is imaginary. Okay? So we're still going to do everything the same way. All right? We still need to figure out what our values are. Okay? Now, if we have an imaginary and it's positive 2i, what do we also have if it's imaginary? A negative 2i. So like if it's x equals 3 and x equals 4, and I have an x equal to 2i, then I also have an x equal to negative 2i. So then, just like we did on 86, I'm going to go back through and I'm going to have x minus 3 equal to 0. I'm going to have x minus 4 equal to 0. And I'm going to have x minus 2i equal to 0, along with x plus 2i equal to 0. Bless you. So, now I want to do it kind of the same way, but here's what I'm going to do in this case. Okay? I don't want to deal with the imaginary numbers. So the first thing I'm going to do in this case is I'm going to go ahead and multiply these two together. Okay? Then I don't have to worry about any sort of imaginary values or anything like that. So whenever I do that, whenever I take x minus 2i and x plus 2i and I multiply those two together, I'm going to get x squared. I'm going to get a positive 2i, I'm going to get a 2ix, I'm going to get a negative 2ix, and then I'm going to get a negative 4i squared. Now, what is I squared, though? It's negative 1. So, if this is negative 1, what's negative 1 times negative 4? Positive 4. What's going to happen right here? They're going to cancel. So I would rather deal with x squared plus 4 and then do everything the same way and solve for my a. So now that I have an x plus 3 and I have an x minus 4 and I have x squared plus 4, I'm going to do the same thing I did on 86, and I'm going to set 16 equal to a times 2 minus 3 times 2 minus 4 times 2 squared plus 4. Okay? And still solve for a. So whenever I do that, I get negative 1, negative 2, 4 and 4 is 8. Still have the a, and I have the 16 here. So I have 16 equals a times 16. Right? Yeah. So what's a equal to? 1. So there's no scale factor here. That's okay, but I just have to make sure before I do anything else. So there's not going to be anything that I have to multiply anything for or anything to. So from here, all I would do is I'm going to take my x plus 3 and my x minus 4 and my x squared plus 4, and I'm going to multiply everything together. So whenever I do that, I'm going to have x minus 3, x minus 4, and x squared plus 4. It doesn't matter to me what order you do. The thing that I would just tell you is do 2 at a time. So for me, I'm going to go ahead and do these two first and have x squared minus 7x plus 12. I'm going to take those two and then I'm going to multiply with x squared plus 4. As far as what you do and how you want to do it, if you want to draw the table, draw the table. If you want to distribute, distribute. Okay, again, it does not matter to me how you do it. I feel like a lot of you or a lot of students would rather just do it this way, okay, and kind of go this route, which is completely fine, and take my x squared, my negative 7x, and my positive 12, and then take x squared and my positive 4, and then just start multiplying. X to the fourth minus 7x to the third plus 12x squared plus 4x squared minus 28x and plus 48. And then just combine like terms wherever I have them. So I only have two that are like terms. So x to the fourth minus 7x to the third plus 16x squared minus 28x plus 48 is what f of x, whoops,